So here's the idea. I want to take all the big components off of this board, including the screen, because I want to see where all these little traces go, these little lighter green color lines that you see on the board here. That's copper that's been covered with a green solder mask. The solder mask prevents solder from getting onto the copper, so only copper will solder will flow on the exposed copper bits, which have been pre-tinned with lead or something. So I want to get all these components off so I can see where all these traces go, because a lot of them go under here, go under the chip, go under these components, and I don't know where they go. So to do that, I'm going to use a hot air station. This one is a very cheap one. I bought off eBay for like $35 maybe. The professional ones cost hundreds of dollars, so there's no middle ground. It's the very cheap one or several $100s of a professional one. So the first thing I want to do is take the screen off, because I think the screen is prone to melting if I use this hot air gun too much. So I'm going to get under here and pry it off. You can see that there's this little flat flex cable that's been soldered to the board, so I need to free that. And I'll try it with the hot air station. I don't know if this is going to work. You could probably get rid of that or pull that off with just a traditional soldering iron and some solder wick. But let's see if I can use everything. If I can get everything off with just the hot air station. So I'm taking some Captain tape here, and I'm not only going to use it to tape the screen down, but the tape is an insulating tape. It's the same sort of stuff. Actually, that might be too much. It's the same sort of stuff that was used by on like the Apollo missions to protect the spacecraft and the lunar lander from the very harsh conditions, the deep cold and the deep hot there. Deep hot, sure. Okay. We'll see how that goes. I'm gonna turn this thing on. Oh, I need to plug it in first. There. Okay. Turn it on. And I'm gonna run it at 350 degrees Celsius. I find that seems to be the most effective range. And this is going to take a couple of minutes here, because you got to sort of heat the whole board up. So I'm going to start with the gun a few inches above it, and I'm just going to try heating the whole board up here. That way when you get in close and you start to really apply the heat, because the board's already warm, the heat's not going to be sunk away to the rest of the cold board. Again, I have no idea if this is going to work. But if we're lucky here, the flat flex will just pull itself off of the board, because it's got a little bit of force being applied to it, because the screen is bent back like that. And it should just pop right off the board, in theory. I can see some flux on the board is melting and wiggling around now. And I start getting in close here. It's not popping off. Let me see if I can get it with the tweezers here. Yep. That's all it takes. There it is. It is off. And while the heat has definitely affected the some of the adhesive stuff, you can see there's a little block of adhesive here, and now it's come off. I'll have to replace that. But now the whole board is fairly hot. Now I gotta get this Captain tape off, which of course is now very stuck together. Oh. Alright, I guess I will be using the soldering iron just to get rid of those two wires. Those two wires that you see right there, the red and blue, those provide the backlight for the LCD screen. So I just gotta wait for this to come up to temperature. My soldering iron is in Fahrenheit. I have it set at 65 right now. I usually waver between 650 and 700 degrees Fahrenheit, which again is around 350. Okay, there we go. Just come in here, heat up the pad, the solder melts, and the wires come off. And there is the LCD screen, in theory still in working order. The Captain tape I'm not going to take off. I'm going to let it cool because I suspect that adhesive is going to come off right now because it's warm. So put that off to the side. Alright, what is next? We can take these buttons off. You can see these are snappy buttons. They're just little dome pieces of metal. When you push on the metal indents and presses against the board, making contact. These are just held on with tape. There is no soldering here or desoldering required. However, we'll need something to get a hold of the corner here because this thing is pressed tightly against the PCB. Let's see if you can see that there. There it is, and I tore it a little bit there, but that's okay. Worst case, I can use fresh Captain tape and tape them down, and that will be fine. Alright, so everything is off on this side. Now we switch over to this side. And we have a lot of little components here. I don't care about the little components. I'm fine with leaving them on. It's the big ticket stuff, like the chip and the SD card are the biggies. I'll probably take the USB one off as well, just because there'll be some traces going underneath it, possibly. So we'll start with the chip. That's the easy one. Let me turn off my soldering iron. Bring in the hot air gun again. And we'll start going to town again. Here, I'll zoom in a little bit for this one. And let me do one more thing here. Let's see where I'm zoomed in. Let me just do a little permanent marker dot right there. So that way I know how to keep this board in shot. Alright, so same thing as before. Start out high a little bit. Get the whole area warm. The mat that I am working on, this blue thing here, this is an anti-static mat that is also heat resistant, so it doesn't melt if you jab your soldering iron into it, or if you do work like this. And I'm going to come down a little bit more. You're not going to be able to see the chip because I'm blocking the view now. I'm just making motion a circular motion around the edge of the chip where the pins touch the PCB. we doing? Not yet. About 30 seconds to a minute, probably. There we go. There's the chip. Focus. Focus, come on. Don't focus on my hand. So I'll put that off to the side for now. So let's keep the party train going. Let's go for this USB connector here. Now this is just a big lump of metal here, and I gotta heat the whole thing up to 300 degrees here, 350 degrees Celsius. The pins on the back, the connection where the pins on the back connect to the board, those will come off pretty easily. It's the joints on the board here on the ground plane that are being used to hold the USB port in place. Those are the ones that are going to take a lot of heat before they'll come off. Sometimes you can, when you're doing this, you can watch the solder, and you can see it start to get really shiny and move around a little bit in the stream of air coming out of the gun, and then you know, okay, it's time to pull it off. But most of the time, like with that chip, there was no way to tell because my eyes aren't zoomed in that closely to the chip and the joint, so I just tested every 10-15 seconds. Yeah, the front joints look like they're ready to come off. There we go. Let me show you that. There's the underside of a USB connector. Focus. Ow. Okay, not focusing. Gonna have a little USB imprint on my hand now. Alright, what's next? What is next that we want to take off? I guess it's gonna be I don't know. Is that phone jack there? Is that audio jack rated? Is that made of a certain type of plastic that's heat resistant so I can put the hot iron on it? Let's find out. Hot iron, hot air gun. I mean, if not, this thing cost me $1.50, this MP3 player. Not a big deal. I'm just really curious about this MP3 player. I have other MP3 players that use the same family of chip, but this one's wired differently. And it has an LCD screen on it. So I'm curious, is it the same chip just wired differently, or is it a different chip entirely? In my research for this chip, I have not found a datasheet for any of them, which is annoying. I found a couple sellers on a Chinese website. Well, it's not Chinese. It's run by a Chinese company. It's called AliExpress, which is sort of the international interface to the Chinese website Alibaba. And I found some people selling chips like these, and I emailed them. I said, hey, do you have a data sheet? I'm waiting to hear back. One did reply and said, yeah, we have them in stock. How many do you want? And it's like, no, I want the datasheet. Give me the datasheet and then I'll tell you how many I want. But also in my my internet researching, I saw a reference to to something that seemed to indicate that these chips could do FM radio or MP3 player. So I wonder if there's a way to rewire these chips and turn them into a radio. I actually have an FM radio kit that I bought off of eBay years ago and built, and it had a little pin, like a little chip like that too. So I wonder. This thing is not going to want to come off easily. I think part of the problem here is the metal jack that's inside this, the metal pins that hold the headphone jack, the headphone wire, plug, whatever you want to call it. Those are probably sinking a lot of the heat. That's probably part of my problem here. So I probably need to just really blast a ton of heat and just be patient. I don't smell any plasticky burning, which after exposing it to this kind of heat for this long is a good sign that the audio jack here is heat resistant. There is some plastic inside the SD card socket that's right next to it that I'm pretty sure is not heat resistant. The other MP3 player I took apart like this, the socket was destroyed because some bit of plastic melted. Okay, there we go. Needed a little extra force there. Let's just make sure I didn't strip any pads. And you can see the solder didn't really melt. It was all being sucked away by the wires and the jack there. But it came off and none of the pads are stripped. Alright, what is next? I could take the switch off. Could take the switch in the top left there off. I don't know that I need to. Putting it back in is going to be a little finicky. And the wires on the edges here, the connection on the edges, those go to ground. And the 3 wires that connect to the switch come away from the switch. So there shouldn't be anything underneath there that I need to worry about. So I'll probably leave the switch alone. Alright, so here we go. We're going for the socket card now, or the SD card holder. This one's going to take a lot of heat because of that big metal body, the shield. Something that's kind of interesting about this particular MP3 player layout. On all the other ones, all these MP3 players have a tiny little battery, a little lithium polymer battery that you charge up via the USB port. But with lithium polymer batteries, you got to worry about overcharging them and over discharging them. And so usually anything with a lithium polymer battery in it has a circuit that specializes in protecting the battery, shutting access off to it when it gets too low or too high in voltage. And it looks like the other MP3 players I have, the chip has a built-in piece of battery protection because the battery goes right to the chip. And I measured the charging voltage coming out of the chip, and it was 4.2 volts, which is bang on what you want. This MP3 player is different because I think they needed extra pins. They don't have a battery charger in this MP3 player chip. So instead what they do is they are sending the voltage from your USB port directly into the battery via a diode and a resistor to limit the current that goes into it. How are we doing? Are we even close? Not even close. Back at it. So when I measured the current, or not the current, the voltage going into the battery when the USB is plugged in. Ow. Why are you not laying flat all of a sudden? Because you're suddenly developing a bow. That's interesting. Or the mat's expanding because it's getting hot. Anyways, because I have to apply heat to this thing for so long. So where was I? The charger. Yeah, so I measured the voltage going into the battery, and it was 4.8 volts, which if you charge the lithium polymer battery up to 4.8 volts, there's a good chance that that thing is going to not enjoy that and express its unpleasantness by leaking or even exploding. So this is not the best MP3 player if you care about, exploding electronics. Now what you could do is you go online and buy a lithium polymer battery that has onboard protection. Like a lot of these batteries have built-in chips, a little PCB, so that you don't have to rely on any external circuitry to protect the battery. I could buy one of those, or even maybe find just the board itself. I actually have a protection board for a smaller battery that I pulled off of a battery that blew up before I even opened up the item that I had purchased. Maybe I could stick it onto the battery that's for this one. How are we doing? I might have to get a little forceful here now. This is taking a long time because, again, all the heat is going into that metal plate cover here and then immediately being radiated out. I could kick the temperature up to like 400 degrees. But I think what approach I'm going to take, you can't see that right now, is I'm going to focus on an individual joint. Let's just hold that apart while the solder melts a little, or cools a little bit. My board is really hot. Alright, there's your underside. Not interesting. Actually, you know what, I'll leave that running for a little bit. When the, oh well. There we go. When you leave it in the stand after you've been using it for a little bit, you put it back in the stand, the thing knows it's in the stand. I'm talking about the rework station, the hot air gun thing here, this thing. When you put it back in the stand, it knows that it's there, and it will keep the fan running to help cool it down more quickly. So that's what I'm going to do. I'm going to leave it running. So here is the board, depopulated, and let me grab a better pointer here. This is the kind of stuff, this is why you want to do something like this. You can see, oh, come on, focus here now. You see this trace coming in from the right, and then it ducks down here. Well, look at it and its thickness, and if you still had this SD card socket on it, you might think, oh, it just goes straight through to the other side. It lines up perfectly. But now we see there are two separate lines there. So then what you would do to trace this out visually without even using a multimeter or anything, you look at it, you say, okay, oh, come on, look, we're going to look for this big hole here, and then we're going to look for this cluster of 4. Big hole here, and there's the cluster of 4, and then you can start following it. Look for, see, you got another via, flip it back over. There's the other via, and it comes down over here, and it goes over to all of these resistors. All of these resistors, I believe, go to different buttons, and I think it's using different combinations of resistance to detect which buttons are pressed. I don't know, that was my theory before I desoldered everything, so we'll figure that out. It's interesting, it's got a space for another little chip here. I might have to look at how that's connected to see if there's something obvious there about what that does. My guess is this is probably something to do with the LCD display, and the chip isn't needed. Come back, LCD. Because the LCD display has a chip on it. Can I remove this Captain tape now? Good enough. Do you see that silver rectangle at the base there? That is a chip. That is a chip to drive the LCD So a lot of the functions that would be on the PCB for the LCD display are here on the chip, on the display already, so you don't have to worry about it. That's why you don't need 100 pins here or anything like that. And see, now I can see the flat flex cable better. I can see that there are some pins that clearly, I don't know, it looks like they all do. Oh, these two pins, those two pins right there don't seem to go anywhere, but everything else goes up. So when I'm tracing out where everything goes, I can ignore those two pins that clearly don't go anywhere. Alright, so there you go. There is your depopulated PCB using almost nothing but hot air. I did have to use the soldering iron for those 2 points for the backlight. I could have used the hot air station too for that, but it was just easier with the soldering iron. So there you go. Hope that was interesting. Now I'm going to take some pictures, get some close-up views of how this thing is laid out, and start figuring out how everything is wired together.